So come to load flow using Newton-Raphson method, right? And for this case, uh, although computation, other things, as far as classroom is concerned, it will be hardly one has to in calculator you have 2 into 2 or 3 into 3 inversion of matrix, that is possible. Otherwise, everything you have to do, I mean, when you large problem, you have to do it using your what you call that computer. Without that, you cannot do it. So load flow, when you will do these two equations, we have derived equation 15 and 16 of this chapter. So Pi is equal to this much and Qi is equal to this much. That is power injection at bus I. Pi is this much. Earlier we have this is from equation 15 and this is equation 16, right? But again, renumbering this equation 50 and 51, same equation, but for the sake of clarification, same equation but renumbering. This is 50 and this is 51. That is 7.50, 7. This is chapter 7, right? So these two equations are there. Now, whenever you form the Jacobian matrix, right? So question is that how to form it. Bus 1 is a slack bus, right? And all buses are PQ bus. All buses are PQ bus. That is, every bus net power injection P and real power P and reactive power Q both are known, right? And bus 1 is a slack bus. That means that the slack bus, that power P1 and if slack bus is 1, right? Or if that is power P1 and Q1 will be computed after the solution has converged. So, and second thing is, at the slack bus, voltage V1 and angle delta 1 both are mentioned, right? So specified. Therefore, when you form the Jacobian, the way we have defined here, this is mathematics, right? Any mathematical book, any mathematics book in numerical methods, you will find this is mathematics. Different book give different way, but here we have given in different way, right? But a similar thing you will find it. So whenever you put the formula as Jacobian, so bus 1 and mismatch power is delta P, or what you call at bus 2, bus 3 power mismatch you have to calculate. Mismatch means all buses are PQ bus. That means at buses net power injection Pi and Qi are known for I is equal to 2, 3 up to n number of buses, because bus 1 is a slack bus. And mismatch means that I told you that it will be calculated power minus scheduled power. That means that is known power injection, that is P2, P3, Q4, these are known power injection. And calculated thing means using this formula Pi or Qi you have to calculate, and whatever you have calculated and whatever specified, both you have to take the difference, that is a mismatch, right? And that is actually, that is whatever is given here. So delta P2 means, for example, that is the mismatch of the power, calculated powers and scheduled power. Later you will see. And Jacobian this side, similarly for delta Q2, this is 2 to n, this is Q to n, if bus 1 is a slack bus, right? And this side, and before coming to the mathematics, this side at the your slack bus, voltage and your delta both are known, that is V1 and delta 1 known. So delta 1 is specified, so no question of delta 1, but these are the mismatch of the angle, delta 2, delta up to delta n, right? So this is your, this side also given pth iteration, this is also pth iteration, this is also pth iteration. And similarly at slack bus, voltage specified, voltage magnitude is also specified, so one will not come, it will be delta V2 magnitude up to delta Vn pth iteration. Now after making this is very simple to make it, because this is delta P2, so basically it will be del P2 upon delta 2 into delta 2 plus del P2 upon delta 3 into delta 3 up to delta P2n and delta P2 delta n into delta n, right? Just to make this, after that looking at those things, you automatically you can know what will be the derivative, right? Similarly up to delta P2 upon delta n. Similarly next one will be delta P3 upon delta 2, delta P3 upon delta 3 and so on, right? With this matrix. Similarly, when you take this your reactive one, same philosophy, delta Q2 upon delta 2 into delta 2 plus delta Q2 upon delta 3 into delta 3, right? Because it is a book, so all these things cannot be accommodated because things will be larger. But this is the thing, this is all dot, so all elements will be there, right? So this matrix, so first you have to make the left hand side. then the right hand side, right after that all these element accordingly you can put, because delta p2 will be delta p2 upon delta delta 2, then del plus delta p2 upon delta delta 3 into delta delta 3, and so on, right? So this matrix, if you define it is J1, if we define this is as J2, if this matrix is J3 and this matrix is J4, right? So therefore we can write delta P delta Q, that is J1, J2, J3, J4, and this is delta delta, this is delta V, right? So delta P is equal to this vector delta p2 delta p3 up to delta pn. Delta q will be delta q2 delta q3 up to delta q1. These are bold actually, that's that's why it is written. Now delta delta is equal to delta delta 2 delta delta 3 delta delta n. Similarly delta magnitude v is equal to delta v magnitude v2 delta magnitude v3 up to delta vn. So this was j1 j2 j3 j4. This now what is best from your intuition you can make out total number of buses is n. Bus 1 is a slack bus. So here delta P1 is not there, delta Q1 is not there. Here delta delta 1 is not there, here delta V1 is not there. That means each matrix, this is n minus 1 into n minus 1, this is n minus 1 into n minus 1, this is also n minus 1 into n minus 1, this is also n minus 1 into n minus 1, right? That means overall, if you take, so basically this whole matrix will be 2 into n minus 1 into 2 into n minus 1, right? Each one is n minus 1 into n minus 1. This is also n minus 1 into n minus 1. This is also n minus 1 into n minus 1. This is also n minus 1 into n minus 1. So whole matrix will be 2 into n minus 1 into 2 into n minus 1. So each J1 is n minus 1 into n minus 1 matrix, right? But in real power system, what happened that if there is a slight change in real power, that is megawatt, it affects your what you call that voltage angle, right? It affects the voltage angle but leaves the bus voltage magnitude unaffected, totally unaffected, right? Similarly, if there is a small change in reactive power, it affects the voltage magnitude, but it doesn't affect the voltage angle, right? That means this is more or less common philosophy in power system. That real power changes, it basically affects your that is your angle delta, but leaves the voltage magnitude essentially unaffected. Similarly, for this one, if you change the reactive power, then generally it affects the voltage magnitude but leaves your what you call that your voltage angle unaffected. These things little bit I'll teach you later when I'll teach little bit of control system. At that time I told you that why these things happens, right? That means this J1, J2, J3, J4, that means from this matrix what we can do, J2 and J3 we can drop, because this change in this will be very small, here also in this very small, right? Therefore this is actually called coupled Newton-Raphson method. When P is related to both delta and V, Q also related to delta and V, right? This is called coupled Newton-Raphson method. Coupled Newton-Raphson method is true for distribution system. I mean, when voltage level is only 11 kV or below that, at that time you have to use coupled. If you want, you have to use coupled Newton-Raphson load flow method, because otherwise solution it will not converge, right? It will diverge. So coupled Newton-Raphson method for the low voltage distribution side, it will work. It will work because I myself I have written code of this thing of my own, right? So I know this. So question is that if you use the now for transmission system, we will go for decoupled load flow, because this is actually true. That means J2 and J3 will be dropped. If it is dropped, then this is called decoupled. In that case, what will happen? Delta P and delta Q is J1. This is 0. This is actually 0. That is 0 matrix. All elements are 0. This is also 0 and J4. So for easy computation, so J2 and J3 will not be there. If it is not there, then delta P can be written as J1 into delta delta, and delta Q is written as J4 into delta magnitude V, right? I will tell all the time delta V, understandable, it is magnitude V, right? So this is actually J1 matrix and this is your J2 matrix, right? Sorry, J4 matrix. Now, in this case, what happened? That there may be your what you call in a system, there may be m number of PV buses. Suppose you have total number of buses n, one bus is slack bus, and you have m number of PV bus, then the remaining buses will be n minus m minus 1. Those are PQ buses, right? So in this case, what will happen? the J1 will be n minus 1 into n minus 1. This J1 will be n minus 1 into n minus. If all buses are PQ buses, then it is n minus 1 into n minus 1, n minus 1 into n minus 1, n minus 1 into n minus 1, n minus 1 into n minus 1. But if you have m number of PV buses, then one bus is slack bus, so total number of buses is n minus 1. If you have m number of PV buses, right, and PV buses means where voltage magnitude remain constant, right? Therefore, J1 will be n minus 1 into n minus 1 because it is related to delta only, and if it is PV bus means voltage magnitude is constant. So m number of PV buses you have, then this J4 matrix in general, J4 matrix will be your n minus 1 minus m into n minus 1 minus m. The m is number of PV buses, right? If m is 0, if no PV bus, then n minus 1 into n minus 1. Right. Now, once you get it, now if you come to the J1 matrix, you have to find out delta P2, delta delta 2, delta P2, delta delta 3, all these elements. Similarly, when you come to delta Q2 upon delta N, this except PV buses should not be there because voltage magnitude remain constant. So, but all this, your delta Q in general, delta Q to delta VI, you have to compute. Right. So when you do so, now we have seen this, the Pi is equal to this and Qi is equal to this. Now this one with respect to delta we have to take the derivative, and this one Q with respect to voltage magnitude we have to take the derivative. Right. Therefore, in this case, when you go for this, is you try, very interesting. This will try. When you find in general diagonal element means delta Pi upon delta delta I. That means delta P2 upon delta delta 2, then delta P3 upon delta delta 3 up to delta Pn upon delta delta n. Similarly, here also delta Q2 upon delta V2, delta Q2 upon this Q3 upon delta V3, delta Qn upon delta. These are the diagonal elements, right? These are the diagonal elements. So in general, when you make the diagonal elements, right, so say ith diagonal element, there is delta Pi upon delta delta I. You take the derivative with respect to delta Pi upon delta delta I, right? If you do so, you will get k is equal to 1 to n, but k not is equal to I. It is Vi Vk Yik sine theta Ik minus delta I plus delta k. It will be summation of except k not is equal to I, summation of all the elements. I will suggest little bit for your own thing. You take, for example, n is equal to 3, expand it. Right, and then you find out delta P2 upon delta delta 2. Just you find out. Then you will see it is not a single element. It is k not is equal to 2, but all other 2 elements will be there. So that's why what you do, if you take delta Pi upon delta delta I, this is a summation. Right. When you take off diagonal elements, that is your, for example, delta P2 upon delta delta 3, delta P2 upon delta delta 4, like this. Off diagonal elements, delta this one. Then in this case, delta Pi upon your delta delta k will be minus of Vi Vk Yik sine of this thing, right? Because your what you call this is your cosine. When you are taking the derivative with delta k, so it will be minus sign, right? When you are taking it as minus, 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 plus. That's why diagonal element symbol was plus. But when it is plus delta k, minus delta I plus delta k, so cosine derivative is minus, right? And you are taking this delta Pi upon delta delta k, right? That's why it is minus symbol, right? So minus Vi Vk Yik sine of theta Ik, that is k not is equal to I. Here it is written k not is equal to I. This is equation 57. This is in general. This is your diagonal element. This is your off diagonal element, right? Similarly, for diagonal elements of J4, delta Qi upon delta delta Vi, you will get this one. You take derivative, this ith term out, right? Minus 2 Vi, this thing. But anyway, so here only single, because it will come when k is equal to I, it will become square. That's why this 2 is there. One can be added, one can be kept outside, right? But anyway, so minus 2 Vi Yii sine theta, then minus k is equal to 1 to n, k not is equal to I. This is your Vk Yik, whatever it is, sine theta Ik minus delta I plus delta k. Similarly, if you take off diagonal element, delta Qi upon delta Vk, then only single element, but k not is equal to I. Here also k not is equal to I, right? If k is equal to I, then it will not valid, right? Because it is k not is equal to I, right? This is diagonal element, this is off diagonal element. Now, when you get the delta P2, delta P3, whenever you will calculate, the delta Pi is equal to Pi scheduled minus Pi calculated. That is, calculated means that every iteration using that equation, using these two equations, every iteration you have to compute. And this power and schedule power, this power is known. This is known, but this is calculated. You have to see these two are approaching to 0, right? And every iteration you have to update voltage magnitude, you have to update. Current iteration value is equal to previous iteration value plus the correction factor delta BIP, that will come from that equation, and delta IP plus 1 is equal to delta IP plus delta delta IP. This is looks like very simple only, right? And only thing is that few lines you have to write the code. So first thing is you have to read system data. System data means you have to read the RX value, load values, many things are there which are beyond the scope, right? Then load data, then slack bus voltage, slack bus angle, PV buses, if voltage magnitude specified, those data, all these things you have to read. And after that, you have to make you have to form Y bus matrix. If you are very strong in coding, a little bit if you understand, this Y bus coding hardly will take 6-7 lines for this code, right? Automatically it will take. But before that, you have to convert that RX value to your G and B value. After that, you have to make it. Then for load bus, these two are specified. So this you have to calculate. Slack bus voltage, you have to, this is actually V1, right? This is not your, this is no, voltage magnitude and are set equal to the, this is that your, what you call that starting values. This is actually voltage magnitude, that's the means for load buses, these are okay. Voltage phase angles are set equal to the slack bus. That means all the buses. Suppose bus 1 is a slack bus. Suppose it is 1 angle 0. So initial values you have to take. You start with flat voltage start. This is called flat voltage start. But this is for I is equal to 2 to n. Right. If voltage magnitude are specified, that is different. That also you have to consider. But these are the initial values, right? And then your what you call for voltage control buses, this voltage magnitude and PI schedule are specified, right? And slack bus voltage angle is 0. And PIQI using equation 50 and 51 or 15 or 16, whatever it is, you have to compute, you have to calculate, right? And delta P and delta Q from equation 61 and 62, you have to calculate, right? And if it is a voltage control bus, then PIP are computed using equation 50 and 61. So these are standard and compute elements J1, J4, that also you have to compute. I mean, in the code, you have to write generalized code, right? You cannot type all the single element 1 You have to make generalized code, right? And after that, you have to see max absolute of delta Pi and max absolute of delta Qi at a particular iteration. If it is less than epsilon, then solution has converged, right? This is the simple thing. But I will take the same example for the purpose of explanation, because my philosophy, always I feel whenever we teach a theory, that every theory must be supported some examples such that a student can easily grab it, right? This is my philosophy. If you see my NPTEL course, this is also recorded in NPTEL and it is available in YouTube, right? I have four NPTEL courses, one is power system analysis, and it is there in power system analysis. Another is power system engineering. Another is for the first year level, that is fundamentals of electrical engineering, right? Another is PG level, that is power system dynamics control and monitoring, right? So 3 are undergraduate courses, and everything is available in YouTube, right? So there also, if you look into my NPTEL courses, there you will see how I think I have tried my best. You can have a look, right? So this is available in YouTube, and these courses are ongoing courses, right, in NPTEL. Because all over India, many student faculties, they take those courses, and they write exam also. Remember, I said the question paper for this thing. If I give 1 or 2 question paper for this in online mode, then you will see 1 or 2 questions how different it is than whatever you get, right? So in any way. So same problem, whatever we took from Gauss-Seidel, you will get a different result here, right? Because there is 2 iteration in Gauss-Seidel and 2 iteration in Newton-Raphson method. Both will be different, right? Because Newton-Raphson's convergence rate is much faster than Gauss-Seidel. I told you yesterday that it is quadratic, but proof will not be given, right? So from equation 50 and 51, same example, that is your same example, your example 7.2. Using decoupled Newton-Raphson method, you have to solve and perform 3 iterations. 3 iterations I have taken here because that here computation will be less than the Gauss-Seidel, I believe. Right? Just see how I have made it. Right? Just for the classroom purpose. Right? Same data. So first you 50-51. Bus 1 is a slack bus. So P2, P3, Q2, Q3, all the whole equations you write. Right? After that, you take delta P2 upon delta delta 2, right? So if you take the derivative, this is the thing, then delta P2 delta delta 3. This is the derivative. Look, if you take that, this is diagonal element 1, right? Delta P2, then look, two terms are there because one bus is slack bus, so two terms comes there. And delta P2 by delta 3 off diagonal elements always will be single time. You take the derivative, you will be right. Then delta P3 by delta delta 2, this is also off diagonal element, right? But delta P3 by delta delta 2, this is diagonal element. You take the derivative of this equation, delta P3 upon delta delta 3, then you will get this. Similarly, delta Q2 upon delta V2 magnitude, all buses we have assumed PQ bus. All buses we have assumed PQ bus. Yeah. Right. So delta V2, Q2 upon delta V2 is this one, and delta Q2 upon delta V3 is this one. Delta Q3 upon delta V2 is this one, and delta Q3 upon delta V3 will be this one. I have given this or your what you call all these diagonal or off diagonal elements because it is a 3-bus problem. It is a 3-bus problem. So one bus is a slack bus. So 3 minus 1, 2. So J1 will be 2 into 2 and J4 also will be 2 into 2 matrix, right? So total will be your what? 8 elements. 1, 2, 3, 4. 1, 2, 3, 4. Total 8 elements, right? After that, the data were given previously all these things are computed, right? In this case, we are taking the same voltage magnitude 1.05, delta 1 is 0, right? And all other cases, initial voltage is 1 and angle is 0. Initial voltage is 1. These are zero iteration means starting values, right? This is 0 means zero iteration, that means starting value. And this slack bus voltage is specified, right? Using all this data, all these elements are computed using all this data, right? You calculate your delta P2 upon delta, substitute all, you will get this value. Substitute all, you will get this value. Substitute all, you will get this value, right? Similarly for delta P2, all these things you have to compute. After that, the starting value of J1 0 is this much because this is delta P2 upon delta delta 2, delta P2 upon delta delta 3, this is delta P3 upon delta delta 2, this is delta P3 upon delta delta 3. And this is J1 0 and this is J4 0. So all these elements are computed. All these elements are computed, right? And this matrix is given. Now for this problem, J1 and J4 has computed about what I have done it. This J1 and J4 we have not computed in the second iteration because in the second iteration you will have voltage magnitude, you will have new voltage magnitude, you will have new voltage magnitude. Again you calculate the computation will be heavier, right? So what I have done it that for the sake of understanding that this value will not change in mass, right? So this value will be every iteration. So no need to calculate, no need to calculate, right? Therefore, using the initial value P2 you calculate. P2 that is what is initial value of P2. That means P2 means that whatever these equations are there. All P2, 3, why is this P2, P3, Q2, Q3, all these calculate because you have to calculate value. You can initial value, right? P2, P3, Q2, Q3. Then what you do? This P2, it is calculated. This is starting value. Using all these things calculate. P2, P3, Q2, Q3, all calculate, right? Then after what will happen is this Q2 and Q3 the power injection. This value we are got when you are solving Gauss-Seidel method, right? This P2 and Q3 P3 that is go back to the Gauss-Seidel solution. This we have computed. This we know, right? This is actually known values. Power injection, these are actually known values, right? And similarly, Q and Q3 these are also computed. Solving the same problem 7 point to Gauss-Seidel. This is also known values. Therefore, delta P2 will be P2 minus P2 calculated initial values. This much. Then delta P3 will be this much. Then delta Q2 will be this much. And delta Q3 will be this much. Right. So that means all delta P2 starting values, delta P3 and delta Q2 initial values are known. Right. This is that your delta. Then this will be delta P2 0, delta P3 0. Right. And this will be your J1 matrix. And this is delta Q0 and delta 3 0. That means delta 2 0, delta 3 0 is starting values or initial values, right? This is inverse, this 2 into 2 matrix inverse. In calculator, easily you can get it. This is inverse into delta P2 0, delta P2 0 is this much, minus of this much, and delta P3 0 minus of this much, right? And then for this is your delta 2 0, and this is your delta 3 0 radian, right? So similarly, your what you call that your delta, similarly delta q0 0, delta q3 0, this is J4 matrix, this is delta p2 0, delta v3 0. Therefore this is this voltage magnitude is this much, delta v2, and delta v3 is this much. Therefore delta 2 1 is equal to delta 2 0 plus delta 2 2 0, right? So this will be minus 3.936 degree. Delta 3 1 will be this one plus this one. So it will be minus 2.837 degree, right? So this is radian and this is in degree, converted to degree. Similarly, voltage magnitude in first iteration, V20 plus delta V0 is equal to this much. V31 is equal to V30 plus delta V30 is equal to this much, right? So whenever we write this equation, this is a 2 into 2 matrix, right? This is a 2 into 2 matrix. So I mean, it is very simple. It is very simple. Right. This will be your, I'm just not putting any iteration. This is delta P2, delta 3. Right. This is your delta P2, delta delta 2. This is your delta P2, delta delta 3. This is your delta P3, delta delta 2. And this is your delta P3, delta delta 3. And this side will be your delta delta 2, and this side will be delta delta 3. Similarly for Q, if it is delta Q2, delta Q3, it will be delta Q2 upon delta V2, delta Q2 upon delta V3. Similarly like this, right? You can make it. This is delta Q3 upon delta V2. This is delta Q3 upon delta V3, right? So this way, this equation is written, right? From this from the inspection or intuition, you can write, right? So this is your V3. Similarly, after using these values, delta 2, delta 3, V2, V1, you go to the second iteration. J1, J4, using this value, do not compute J1 and J4 because it is wastage of time, right? Because you will get the result. So no need to compute this. Once you have got this, your what you call this J1 and J4, whatever you have got, retain this in the next iteration. Same value, no need to calculate, right? So in the second iteration, your in the second iteration, what you have to do then, you have to calculate P2 calculated. That means using this new value of V2, V3, delta 2 and delta 3, you calculate P2 calculated. You have, here it is, the final value is written, but you please calculate. That means you substitute those new values in this equation. You substitute those new values in these equations, right? In that new value of V2 and new, in general, new value of V and delta, you substitute here. Slack bus voltage will not change. You substitute here. And then you, if you calculate, then you will get your what you call, that is your, it has gone. Yeah, second iteration. Just hold on. Second iteration. Here you get P2 calculated, then P3 calculated, Q2 calculated, Q3 calculated. Then delta P2, same way you make it. This is calculated value, and whatever your, this is schedule value, and say, and the schedule value will not change. It will constant. It will remain constant, right? And this is your calculation. You see the mismatch. It is 0.064, it is minus 0.426, it is minus 1.107, and this is minus 0.29. So, and this value is retained. J1 value is unchanged, right? And this is your what you call this this inverse into this 0.064 and minus 0.429. So you will get delta delta 1 is this, delta 3 is this, right? Similarly, delta V2 also, this inverse into your minus 1.07 delta Q2, and this is minus 0.29 delta Q, right? So in that case, you will get delta V2 is this and delta V3 is this. Then you update. That is your delta 2 is equal to delta 2 1 plus delta 2 1. This is your delta value. Delta 3 is equal to this one, right? And voltage magnitude V22 will be this one is equal to this one plus this one is this one, and V32 will be this. This is the new values. With this new values of V and delta, again you calculate P2 calculated, P3 calculated, Q2 calculated, Q3 calculated. After that, if you take the mismatch, the solution is converging. Look at the delta P2 value, 0.39. It is decreasing. Delta P3, this one. Delta Q2, this one. Delta Q3, this one. Everything is decreasing, right? And therefore, new values of delta, this value is unchanged, right? And this put minus 0.3. Actually, it is typographical, or what you call, sorry, minus 0.319, no typographical error. And this is 0.040008, right? Therefore, this is your new value of delta, right? As delta delta 2, delta delta 3. Similarly, delta 2, delta 3, the new values you got this one. And delta V2, delta V3, you will get this one. Look, delta V2 and delta V3, it is very small now. Solution is converging, right? And this way, you will get new value of V2 and new value of V3 up to 3 iterations. Here, data is heavy. Rx value, this thing. I think if you write a code, I think it takes 5 iterations to converge because they depending on the data. But due to some sophistication techniques are there beyond the scope, it may take 2 iterations or maybe maximum 3 iterations to convert. This is when all buses are your what you call PQ bus, right? And next one is this is when all when it is one bus is PV bus, like bus one is a slack bus. Look, slack bus, some load is given 2 plus J1, right? And this is a dummy parameter. Only after load flow studies this may be used. This is a dummy parameter, right? It is not required actually for load flow studies, but it is given. This is a generator power is given 0.5 plus J1 per unit. This is PQ bus, so power injection is known, right? And this is your PV bus, right? This is load is given 1.5 plus J 0.6. The load is given, but as generation Q is unknown, so everything is unknown, right? This bus is a PV bus. So voltage 1 is a slack bus, 1 angle 0 is taken. Voltage magnitude V2 is taken your starting values, V2 0 and your this thing, and this is voltage magnitude 3, bus 3 is a PV bus, right? And delta 30 is starting values. Y matrix is given. These data are given. Y matrix for this system, it is given, right? So voltage magnitude you have to maintain at PV bus, that is voltage magnitude, right? So when PV bus is there for small problem, it is very easy to do it, right? As far as classroom is concerned, right? The question is that, so that how will write Jacobian? Forget about P. P is the iteration. First you have to write the Jacobian matrix. That for your PV bus, P both the buses 2 and 3 are known, right? Specified. So that is delta P2, delta P3 will be there. But PV buses, the delta Q2 should be there. Q3 should not be there because bus 3 is a PV bus, right? So here Q is unknown. The Q is unknown. Therefore, you cannot put here your Q3. Only Q2 should be there because Q is unknown. Similarly, this side delta delta 2, delta delta 3 will be there. These are unknown, and only delta V2 is unknown because delta V3 is fixed, right? Voltage magnitude is fixed. So this side delta V3 should not come, right? Then this whole matrix, basically it is a coupled Newton-Raphson method. Whole matrix is a 3 into 3 matrix, right? Basically it's a 3 into 3 matrix. So this is for whatever may be PV bus, but in the case of P, same thing will be there, delta delta 2. But in the case of Q, that delta Q3 is unknown, so here it should not come. And this side also, delta, or what you call V3 is known, so no question of delta V2, V3. That's why this way you will form the Jacobian matrix. So basically this first 2 into 2 matrix, it is actually your J1. And this delta P2 upon delta V2, your actually what? It will be your this column, delta V2, delta V2, delta P3, delta V3, this will be actually your J2. Right. Similarly, this row delta Q2, delta delta 2, delta Q2, delta, this will be actually J3, and delta Q2, delta V2 will be your J4. That means this is 2 into 2, this is 1 into 1, this you drop because we will use decoupled Newton-Raphson method. So delta P2, delta V2, delta P3, delta V2 should be dropped, and delta Q2, delta delta 2, delta Q2, delta delta 3 should be dropped because we are using decoupled load flow. Here it is written decoupled. Therefore, delta P2, delta P3 will be this matrix because this is related to delta. It is a 2 into 2 matrix. Then delta delta 2, delta delta, because this is 0. This is 0 and this is also 0. Right. And similarly, delta Q2 will be delta Q2 upon delta V2 into delta your V2P. Right. So, and P2, P3, all expressions in the previous example, it is there. How this thing here it is there. Here all these things are there, same 3 bus problem, right? So here it is. So all this derivative, whatever is needed, you compute the derivative. Only this derivative, right? You compute, and this is your all the derivative you computed. After this, all the data, whatever data are given here, you compute. It is not the same data as before. The schedule value Pg2 minus PL2, it is this much. Q2 schedule value Qg2 minus QL2. All data is there in the diagram and everything is given. And P3 schedule value is this much, Pg3 minus PL3. I told you in general that power injection is PGI minus PLI. If PGI no generator is there, then that bus PG should be 0, right? So these are the schedule values. These are the known values. And V1 magnitude is getting slack bus voltage, 1 angle 0, and V2 is the PQ bus, right? It is starting values, that is initial values. And here voltage magnitude V3 is always specified. So delta 30, this thing is 0, and delta 3 initial values are 0. So calculate P2, P3 and Q2, you calculate. Whatever value you will get, you calculate. Look, P2 calculated almost 0, P3 calculated is almost 0, and Q2 calculated is almost 0. Therefore, delta P2 is equal to this much, 0.50, delta P3 is this much, and delta Q2 will be this much. Then compute all this derivative matrix, right? Delta P2, delta delta 2, take derivative, delta P2, delta delta 3, all these derivatives are taken before, right? So this is your J1 matrix. This you do not change, keep it as it is, right? Similarly, for J4, it is a single element. For J4, it is a single element. This is a single element, delta Q2 upon delta V2. So it is a single element. So delta Q2 upon delta V2 is your what you call 26. So first you calculate your, this is inverse, 26 minus 16 minus 16, 31, right? So it is inverse, symmetric matrix, it is inverse, right? And into your delta P2 and delta delta P3, right? And therefore delta delta is this much, delta delta 3 is this much. And for delta V2, it will be delta Q2 0 upon this element. So delta Q2 V2 upon is equal to 26. So it is actually, whatever it comes, it is 0.0384, right? And delta 2 1, it will be 0 minus this one. Delta 3 1 will be this much, right? And V2 1 will be this much, right? That just iterative process, Similarly, for P is equal to 1, you calculate P2 calculated, P3 calculated, Q2 calculated, and delta Q, and then you make delta P2, delta P3, delta Q2, right? And this way, same way, you go for the second iteration, and you will get all these values, right? All these values. So this is actually delta delta. Up to second iteration, I have done it. I have also no idea that what will be the number of iterations to converge, because after that I didn't move, and no code was written for this one, right? But this is the result after the second iteration. Are you listening? Do you have any question? Do you have any question?
No, sir.
Listen, exam to it is open book, everything is there. And I will, many of you are there. In the load flow studies, definitely you will get one question in your next exam, right? And the way I will give it, there will be 4 groups, no? I will give it, at that time you try to do. Anybody can make it correct, at least at least 2 iterations of this thing. If anybody is I will check everything. This your other things, fast test also I am checking everything. I found many students, same thing writing, same thing, handwritten may be different, but things are totally identical. It cannot be photographic memory that everything should be identical, right? But in this case, that your what you call that I told you at the same time, 4 5 student handwriting, all not all are checked, whatever I have checked, right? But handwriting, some of them are exceptional, very good handwriting. Of course, handwriting and getting marks exam totally different, that is okay, but I have to appreciate your handwriting. Some of your handwriting is too good. I will not tell the name here, right? But really very good. At least 4 5, at least 4 handwriting I have seen, too good, right? Anyway, earlier also I have seen this handwriting long time back, maybe I cannot recall, maybe 12 13 years or much before that. I found one student from Punjab, right? He was a Sardar, and he was left-hander perhaps, I do not know, but I have seen his speed of handwriting. I do not know your speed of handwriting, but when I used to teach him, right, this thing, and in the class, I have seen in his handwriting and note taking note also. Before anybody, his thing writing will be over, and his speed unbelievable. I didn't see notice such kind of speed of handwriting for any student. I mean, very fast, very fast. Right. I mean, and at the same time, handwriting was very good. Maybe he was left-hander, perhaps, but very good. Anyway, so this is your fast decoupled load flow. This is fast. That means fast means faster than your decoupled load flow. So this is fast decoupled load flow. Some approximation has been made here. This is true for high tension transmission line, maybe 132 kV transmission line or above. But this method is very popular in your what you call for power system engineering in industry. Right, nowadays all commercial packages are available, very efficient packages are available. Right, so equation 57, if you find diagonal element, this was calculated before. Right, if you put your that was k naught is equal to I, and this equation was there, but what is there, ith term is added here and subtracted. That's why it is minus vi square yi sine theta. If you will go back to this equation, that ith term is added here, that's why k naught is equal to I is not here, but subtracted. Right, and if you go 65 and this one, this equation is qi is equal to minus of this equation, k is equal to 110 vi vk yk sine of this. Right, therefore this equation is equal to minus of qi. That's why minus of qi is written minus vi square yi sine theta I. You go to the derivative, it is written k naught is equal to I. But if you add ith term, add ith term here and subtract ith term here, that's why this minus this one. Right, and this term is equal to minus qi. Go back to that equation. Right, equation 51, and therefore it is minus qi minus vi square yi sine theta. Now this one can be written as minus qi minus vi square bii. This is actually your diagonal susceptance, right? Yii sine theta. Now bi is equal to yii sine theta magnitude. Now is the imaginary part of the diagonal elements of the Bose-Einstein matrix. In a practical system, if everything is in per unit, remember, if everything is in per unit, right, then this bii much greater than qi. Right, if everything is per unit, therefore this qi term should be dropped. This is one thing. Another thing, as the voltage Vi is very close to your what you call 1, if I assume that the Vi square may be approximated as Vi. Right, if Vi square approximated as Vi, and this if Qi term is dropped, then delta Pi upon delta I will be minus Vi into Vi. This is a very bad approximation, but it's true for transmission line of high voltage level, right? So this is a very bad approximation, but it works well. Minus Vi into magnitude bii. Similarly, that another thing is under normal operating condition, right, delta k minus delta is quite small, right? Therefore, theta ik minus delta ik plus delta k approximately is equal to theta ik. Therefore, equation 58, if you go back to that, diagonal element delta pi upon delta k will be approximately minus vi vk bik. Right, and you assume vk approximately 1. This is another approximation. Right, I told you very bad approximation for low voltage side, but high voltage light, this is true, more or less true. Therefore, delta pi upon delta k will be minus vi into bk. Right, similarly, the diagonal elements J4 as given by 59 may be written as, here also term is added and subtracted. Right, in this case also that k not is equal to not here, so one term is added and one term is subtracted. That's why this is written minus vi yii sine theta, and this term is qi is equal to minus of this thing, so that's why it is plus qi. Right, and if you take the derivative of this and same philosophy, that this yii sine theta is equal to bi, and same philosophy, this bii is much greater than qi, so qi should be dropped. Right, therefore delta qi upon delta will be minus vi bii. Lot of approximations we have made. Right, and in this case what happened, that if you take theta ik minus, this one is again approximation, your what to, this is actually theta ik not delta ik, this is a typographical error. because delta I minus delta k is approximately very close, so that's why it is approximately theta ik. It is not delta ik, theta ik, right? Therefore, delta qi upon delta vk is approximately minus vi bk, right? Now, if you represent equation like this, delta p upon delta vi and delta q upon delta vi, then this will be minus b dash, this is minus b double dash, right? And this is actually, if you come to this, that this is actually delta qi upon delta vi, right? Where it has gone delta qi upon delta vi and delta qi, and this is actually, it is not delta delta, it is a typographical error, right? It will be your what you call, where it has gone, just told me some typographical. Let me check whether typographical error is there or not. First thing is delta, first thing is your delta p upon delta vi minus b dash delta delta, right? So delta p, first let me go, delta p upon delta vi is equal to minus vi, your what you call this one, your b dash delta delta. Similarly, delta q upon delta vi is equal to minus b dash delta delta, right? So what is this actually? Everything is correct, I think. Whatever is this, that this b dash and b double dash, it is a constant matrix. You need not your what you call, you need not calculate in every iteration or so. Once you compute it, it will remain this thing. But this is 2 per high tension line, and this is fast decouple method. These are the approximation for your exam purpose. This is not required. I will not give you anything on that. Only thing is that the 3 bus problem. One more thing is there that I'll cover in the next class. The transformer is not possible this with this time, right? So 3 bus, maximum 3 bus problem will be given in your exam, but things will be twisted. For 4 groups are there, it will be twisted, right? And little bit all sort of thinking you have to give, that what way I'll give. Last time also I gave it. I found performance was not good, not at all good, right? But I found same mistake. Everybody's case same mistake, right? So, but you have to think. But the way I have solved in this in my book, you will not find in other book that this way every step is solved, right? So thinking from the student point of view, I have solved all these things. So I'm stop sharing now, right? And anyway, and from next week I'll give assignment. I'll give next week, and whatever assignments given from next week, you will get reply one by one. I'll reply, and I'll reply to all of you, those who have sent it. Yesterday I was checking, many of you have sent me, right? But yesterday that final year students, their deadline is today up to 11:59 p.m. I have given one problem. I have given just 7 days time. I have not told anything to them. I have just told the problem, and they have to write the code, and they have to send me the result, right? But I have told, answers are not told, right? So I have to check their thing first, then I will come back to your thing. But you will get reply from next week, or maybe this week 1 or 2 may get reply. If 1 or 2 get reply, don't convey it to others, because one by one, those who have sent it, I'll reply to everyone, right? And reply means only, I will not say if it is right, I'll say yes, it is correct. If it is wrong, I'll say wrong, but don't try to second time, right? But if I say yes, that means it is correct. If I say no, that means it is wrong, right? So I'll that would they reply, because everyone I have to reply. So every time I cannot write everything, so many lines, right? And I will get reply. Everyone, those I have seen it yesterday. I didn't open anyone, but I have seen the other mail that you have sent me, right? So I'll check each and everything, and I'll reply to everyone. If anybody fails to reply, then he or she can send the mail, but everyone I'll reply. So thank you very much. Again, next week, Monday, we will meet. Thank you.